natin. Okay? Okay, ito yung unang pinakita ko kanina. So for you to be guided by your quote-unquote presentation next Saturday. Not only Investopedia, guys, ang daming references ito sa internet. So hindi kayo kukulangin. In fact, sobra-sobra, no? Nagsasawa na lang kayo kung anong gagamitin yung reference. But this is an example, and this also is generated in R. Yun ang kagandahan. Kayang-kaya i-generate ni Quant Mode at saka ni TTR, Technical Trading Rules. By the way, when we install Quant Mode at saka i-load natin siya, automatically nalo-load na rin si TTR as a package. So when you load Quant Mode library, hindi mo na kailangan i-library din si TTR. But okay lang, wala namang mawawala kung i-load din natin. Right? So read through this, okay? And then, of course, use other references. Madami namang references. And then, si Investopedia sa kanya, meron siyang article dito na ito yung sa kanya, according to him, 7 of the most na ginagamit ng mga technical indicators, no? To build a trading toolkit. Ito yung gagawin natin, guys. Ito yung objective ng course na to. For us to build a trading toolkit or a trading rule. Okay? So you can have already an example here. So yung OBV niya, yung AD, accumulation distribution, yung MACD, yung ARUN, oscillator, RSI also. Tapos yung iba ginagamit si Bollinger in combination with other kasi si Bollinger hindi naman siya talagang ginagamit sa sa pag-determine ng buy or sell, no? Ginagamit siya in consonance with other trading with trading indicators. So yan, OPV, AD, yung accumulation. But ibang klaseng AD kasi meron yung W, kaya yung Williams, etc. No? Alright, yung itong AD, ADX, etc. So clear, guys, yung requirement natin for next week. Hello?
Hello, sir.
Yeah.
Tig-ilan po ulit na indicators ang
Hindi
report?
ko pa ma-decide. Siguro mga 8 to 10. Para
8 each po?
8 each. Para kung i-consolidate natin yan, at least may 24 to 30 kayo. Depende kung ano. Ang objective natin, gagawa ka ng 8, pero magkakaroon ka ng 24 to 30. So, depende. Para may na rin kayo, para may reference na rin kayo. Okay, so it's more of parang may group work kayo, tapos i-partition natin para para you're able to have yung output din ng iba sa classmate. All right. Ayan, may stochastic. Of course, may debate kung kasi I think as by now you know, or as far as I think you have met this in your other subjects na when it comes to for example, valuation, or when it comes to investment advisorship, dalawa yung naglalaban dyan. Either yung mga fundamentalists or yung mga technicians. No? Those who believe that it should be based on yung mga fundamentals ng company. Kaya tinitingnan talaga yung mga income statement sila, yung forecast ng cash flows, etc. So these are what fundamentalists use. No? Top-down or bottom-up approach, tinitingnan yung macroeconomics, yung dynamics ng industry where the company is in. So yun ang ginagawa ng mga fundamentalists. On the other hand, si mga technicians, talagang tinitingnan yung price and volume lang. Sabi nila, the magic is in the charts. No? Diyan natin makikita kung dapat ba bibili o magsisell. No? Okay, whatever you believe in, ako personally, I believe in combining the two. Wala namang mawawala kung titingnan natin information from both ends. Okay. All right. So now, ang gagawin muna natin ngayon, class, is unahin muna natin yung nasa dulo, which is a sample of machine learning. So maraming machine learning tools, and I will leave you guys to look at the hindi na ako pupunta dun sa mga sa mga basic, mga fundamental na definition. Okay, I will leave that to you. You're responsible enough to look at what's machine learning, tapos ano ba yung mga tools na ginagamit sa machine learning. We have yung supervised, unsupervised, reinforcement learning, yung tatlong yun. For us, ang gagamitin na natin yung supervised. This is not really a subject in machine learning, but dun sa, when we were coming up with the syllabus, we decided, kasi parang walang, sa MSCF, parang walang subject eh. Di ba? Tama ba ako na walang subject sa inyo na tinatakal nyo talaga yung machine learning? Right, guys?
Wala po, sir.
Wala, ano? So, in fact, siguro yun yung isang talagang sasabihin ko na baguhin dun sa, ina-upgrade naman yung syllabus. Kaso nga lang, hindi naman ganun kabilis kasi ang daming mga requirements. Pag babaguhin mo yung flowchart ng ano ng isang course, iaano pa yan sa ipapa-approve ba yan sa CHED, no? Yeah. Yeah. So, we decided na sige, mag-incorporate tayo ng kunyari, trading software kasi usually hindi naman nako-cover yung buong term, no? May nagiging sobra. So, i-incorporate na lang natin tong machine learning. All right. So, let's open R. Okay.
Ay, sir, pala yung bagong curriculum ata, machine learning na yung ipinalit nila sa trading software.
Ganun? Talaga?
Yun po yung offering ngayon eh, for
Oh,
MSCF.
parang hindi ko na nabalitaan yun. Sa ibig sabihin yung course mismo, machine learning na?
Yun po yung pangalan nung mag-enroll po sana kami. Akala po namin pwede nga doon kami mag-enroll eh.
Okay. Bale, kung ako naging teacher doon, attend na lang kayo. You can attend naman eh. I'll allow you naman.
Thank you po, sir.
Siyempre, Zoom lang naman yan, di ba? So, if you have time, feel free. Okay? Feel free to attend if you're interested. No? But ngayon, at least makita nyo kung worth it ba na na puntahan nyo yung subject na yon. No? In case I'll be the one to handle that subject. Okay, so next ko na to. All right, so yeah. So open tayo ng R markdown file. Share muna ako. Okay. Kindly open a new R markdown file. Doon na lang tayo doon tayo gagawa ngayon. R markdown. Okay, let's give it a title, Machine Learning. And ang unang natututunan sa machine learning is decision tree. So, create tayo ng panibagong R markdown file. Okay.
Sir, hindi po visible yung R niyo.
Sorry. Wala visible. Alright. Yeah. No? Okay, so machine learning decision tree. So as I said a while ago, there are different types of machine learning. Yung pinaka-simple, yung pinaka-popular is yung supervised learning. So, we have several types sa supervised learning. Isa dyan yung decision tree. And decision trees can be used for in lieu of regression techniques, no? Anong subject nyo na nag-multiple linear regression? And what software did you use for that?
Multivar po, sir.
Multivar. Sa multivar nyo yung Sa multivar yung multiple linear regression? Multivar. Dapat medyo advanced yun. Hindi na dapat. Pero diniscuss pa rin yung multiple linear regression sa multivar. And then what software did you use? Naalala nyo? Guys?
Statistika.
Statistika. Okay. Sino teacher nyo? Si Froome?
Yes.
Yes, sir.
Si Sir Froome. Okay. Alright. Okay naman yung statistika. Usually ginagamit niya SAS. Hindi ko alam kung ba't nag-statistika siya doon. Okay, so sige. So open na ano natin ano. Now, may sinare ako sa Canvas na ano na file, okay? Kindly open your Canvas. Okay, ito. Cardio. Okay, let's open it in R. You know how to open. Marunong na kayo mag-open ng ano, di ba? O hindi pa? Kasi panay download tayo, di ba? From ano. Okay, in case you don't know, so ganito, guys, how do we import data to R? There are several ways. One way is to go here. Dito tayo sa environment natin. Okay, go to environment. And then ito, no? Sa ilalim ng environment, you have here your import dataset. There. Okay, we haven't done this before, right?
Not yet, sir.
Wala pa, sir.
Okay, sorry. Kasi usually pag ano, ito yung simula eh. Pero sa atin kasi quant mode kagad tayo. Kaya downloaded from Yahoo Finance. So hindi tayo nag-import dataset. So here, R has a very powerful mechanism to import to load dataset from Excel, SPSS, SAS, Stata, kaya niyang basahin yan, no? Kaya niyang i-load sa R. So for our purposes, since CSV lang siya, we can just use the base, no? From text. Kasi ang data na sinare ko sa inyo is CSV. And then hanapin niyo kung saan niyo sinave yung ano, kung saan niyo sinave yung data na yan. Okay, it's called cardio data. Okay, so this is what happens when you first open it. Okay. So please tell me kung umabot na kayo
Hindi
dito.
ko alam.
Please tell me kung umabot na kayo dito tapos sabay-sabay nating i-load. Okay, here name, pwede niyong palitan yung name na yan. Okay? We can give it another name. Tapos pag in-import yan kay R, kung ano man yung name na whatever name we gave here will be the name of the object that will be uploaded in R. But let's just maintain cardio. And then heading, yes, kasi may mga headers siya, may mga variable names natin. Okay? All right. Strings as factors, let's just not leave that as is now. I'll tell you the importance of that later. And then here, let's import it. Import. And then makikita na natin, no? Ito yung data natin. And then on the console, you'll see here the code that was generated, no? Okay, sige, i-copy natin to para nakalagay dun para next time when you open this, when you reopen it, nakasulat na yung code para hindi nyo na ulit i-import. Okay, so saan na ba siya? Alright, so I'm going to copy this. Control Alt I and then Control V. Tatanggalin ko lang tong greater than sign na to. Okay, so the function that's used is read.csv. Read.csv. Tapos, ito yung pangalan ng data, cardio. And then, ito yung yung location. No? This is the location. This is where I save the file. Kung saan ko sinave yung file, dun ko kasi linink, di ba kanina sa import dataset. So, yan, no? Okay? And then yung view.cardio, kasama na yun. Alam natin itong view.cardio. Papakita niya yung dataset. Okay? All right. So, were you able to follow so far? Guys?
Sir, question.
Sige.
Bakit
Sige.
may warning po yung sa akin?
May warning. Tingnan natin sandali. Okay. Ella, sige nga, paki-share nga yung screen mo. Clinic mo ba yung ano? Strings as factors?
Tinanggal ko, sir, yung check.
Oo, tama. Tama naman. Pero ba't nag-warning message? Strings as factors is deprecated. Strings. Okay. Anong kaibahan niya? Okay. Ano lang to, no? Kasi, I'll explain, no? May mga may mga variables na categorical. Okay? And then yung categorical variables kasi, it can be used as classifiers. No? So mamaya, explain ko pag tinignan natin yung data. No? How about the others? Lumabas ba to? Dapat hindi siya lalabas kasi hindi naman natin clinic yung ano. Baka na-click mo. Na-click mo kaya?
I'll check, sir.
Sige, ulitin natin yung process mo ha. Hindi, ganito gawin natin. I-RM mo. Sige, ganito muna, Ella. Dito sa console mo. Yan. Sa console, sa upper right. Upper right. Yan. I-type mo RM. RM. Small r lang. Small RM. RM. And then open parenthesis, cardio. Yan. Remove natin ha. Remove natin. So wala na si cardio, no? Tinanggal natin. Okay, sige. I-import natin ulit siya. Yan, sige. Tingnan natin kung okay. Okay. Yan. So cardio, okay naman, no? Nagwo-warning pa rin siya, no? How about kay Leonard tsaka kay Kim, nag-warning ba sa inyo?
Wala pong warning sa akin.
Sa akin din wala eh. Hindi ko na alam kung bakit ganyan, Elano. Pero okay lang naman, no? Wala namang wala namang na-load naman siya, no? So I'm not sure why it's giving us a warning when hindi naman natin clinic yung yung strings as factors. Okay? So wala namang problem, Ella, andyan naman siya. No? And then as I said, class, you can copy the code itself. Kinopy ko siya. Okay, I copied it. Tapos linagay ko na dito, no, sa code chunk natin. So that next time when I open this, diretso na lang to. Click ko na lang para i-load ulit. Para i-load ulit si cardio if I need to load it. Para hindi na ako mag-i-import data set. Okay, so let's take a look first at our data. Ito si cardio. All right. So bounds. Ano to, ano? These are medical data to pertaining to the heart. And then may mga descriptive statistics. No? Unfortunately, guys, I forgot to get the metadata. Metadata is data about the data. So always make it a good practice to understand what the data is. Ang alam na natin dito, pounds, tapos hindi ko na kuha yung metadata nito. Which describes ano pa yung ibang dito. But sige, mamaya hanapin ko and then I'll send it to you so that you can, when you review this, you can see what these variables mean. Pero na lang dito, okay, NSP, ito yung category, okay. This is a categorical variable which is represented as numbers. No? So ito actually hindi siya number. 1 refers to N, normal yata yung N, S is suspect, P is, ano ba yung P? Malimutan ko. Pathologic yata. Okay, pathologic I think. So NSP refers to the condition of the respondent of the person. Kasi ito, ang tinitingnan dito kung may, I think kung nagka-heart attack na yung tao, no? Or prone to heart attack. I think this is that data. And 1, normal. Ibig sabihin, wala namang yung tao, walang condition na ganun. S is suspect. Ibig sabihin, may suspicion yung mga doktor na that person has a heart ailment. And P, alam talaga na pathologic yung tao, may heart ailment siya. Alright, so if we check class, no? Class, So class tells us kung anong klaseng variable yan. Okay, class, and then cardio, dollar, and then sa ilalim tingnan natin yung N. Yan, si NSP. Okay? NSP. Alright, so it's an integer. No, 1, 2, 3. Okay, pero we don't want this to be an integer. We want this to be a variable na factor. Iba yung factor, iba yung integer. Pag sinabi nating factor, it's treated as a categorical variable, and not only a categorical variable, it's treated as a classifier. Kasi may categorical variable na hindi factor. Kunyari, let me give you an example. Year level. Year level, kunyari, pros, sophomore, junior, senior, or kasama graduating. That's a categorical variable kasi naka-text yung ano niya, no? Pero we can consider that as a classifier. Kasi pwede nating gamitin yon classifying yung mga pros, mga sophomore, etc. Okay? So, in that case, we can treat that as a factor. No? Factor. Pag factor, sa case ni R, it's used to denote that this variable is used as a classifier. So, ika-classify natin kung 1, kung normal, kung suspect, or number 3, kung pathologic. Okay? Okay so far, guys? Okay, so this actually will be the first time you'll be using R as a tool for regression purposes and ML purposes. Dati kasi panay ano pa lang tayo, panay yung quant mode, panay stocks. Pero babalikan natin yun kasi ano to trading software to no? Alright. So let's see. Now, one way to check the data, okay, we know that the data is already here. I think I mentioned it to you before. Nasa environment na siya. Cardio. So there are 2,126 observations of 22 variables. So it gives us some bit of information about the data. Okay, and then if we click this, babalik tayo dun sa ano niya, sa matrix niya. Yeah. Okay. All right. So some of the ways by which you can understand the data more, parang summary. We can use the STR, structure, no? Structure ng cardio. Okay. By the way, ito, guys, the class will tell us what kind of, sandali, bago ko i-run yan, punta ulit ako dito kasi just to class, and then just to give more explanation para familiar kayo. And then, sabi ko kay R, get the class of from the cardio. Pag nag-dollar ako, it will automatically, may IntelliSense siya, no? It will give us yung mga variables under cardio. So very easy, very convenient. Okay, if you get, for example, LB, right? So this will give us integer din siya, no? Pero up arrow. Let's choose another one. Yung the integer. Dollar AC. I think this is not an integer. Control enter. There, numeric siya, no? Pag numeric kasi, ibig sabihin nun, it can accommodate decimals, di ba? Alright. Tapos pag may categorical doon, ilalagay character. Alright. So let's get the let's learn more about the data. Let's get the structure. Okay. So the structure. Okay. Okay. So this summary of all the variables. And for example, si LB, no? First here it tells us what kind of what's the structure of the object cardio. It's a data frame. And if you watch the video that I recommended you to watch, you know that A data frame is a matrix type of object structure where you have the row names, the first row name pertaining to the name of the variable, and then each row is an observation, unique observation. Okay, so this tells us the class. So integer, ASTB integer. So either numeric or integer. Okay, so wala tayong character, no? Wala mga letters dun sa ano natin, sa object natin. Right? So that's what the structure will give us. Okay, and then we can also use another function is summary. Summary ni cardio. Right. So si summary, it will give us the 5 number summaries plus more. Okay, so ito, ang kikita natin dito yung minimum at saka maximum, no? And then yung first quartile, second quartile, average, third quartile. So yan. Okay, if it's a character variable, hindi siya magbibigay ng ganito. Bibigay lang niya yung number. Kung ilan yung values. Okay, so we have here for each of the variable kasi either numeric siya or integer. Now, mako-compute niya yung first quartile, second quartile, etc. Okay, so let me pause for a while. Clear tayo so far, class?
Yes, sir.
Okay, good. Okay, so welcome to the world of R. Okay, very powerful, especially sa mga ganito, sa mga statistical analysis. Ito talaga yung for me, this is the tour de force, no? As a tool ng R. All right, now ang gagawin kasi natin, mag-ano tayo, we're going to use a package that will do machine learning for us. Tapos ang gagawin natin for this exercise, what we're going to do is we're going to attempt to classify the respondents as to N, S, or P. And then we're going to compare it with the actual value. Kasi di ba may actual value na tayo nito. Yan, yung NSP natin. NSP. Tapos, given some of this data, some of these parameters or attributes, tingnan natin kung kaya natin ma-predict siya kung NSP siya. And then, let's evaluate if our model, how good or how powerful our model is in predicting whether it's N, S, or P. Yun ang pinaka-ano natin. Yun ang target natin dito sa model na to. Okay? Dito sa activity na to, no? So this is an example of a machine learning tool using what we call a supervised learning. Supervised learning kasi alam natin yung output, no? Ang unsupervised learning kasi hindi natin alam, may data lang tayo. Hindi natin alam kung ano yung output doon, no? So what we can do is we can classify the respondents, and example ng unsupervised, no? Cluster analysis, which I think you discussed in your multivar. Ano pa? Cluster analysis, discriminant analysis, etc., etc. No? All right. So dito, so ang variable of interest natin, class, is yung NSP. Sabi natin normal or suspect or pathologic, no, yung actual na value. So alam na ng mga may ano na tayo, may actual na value na tayo ng NSP. Okay. Now first things first, yung NSP natin kailangan muna ma-convert natin to a factor. Okay, remember, ang factor ginagamit siya as a classifier. So, hindi siya parang age, no? Age na numeric or integer. It's not really a value, itong 1, 2, 3. But it's a classification. Yung 1, yung normal. Yung 2, yung suspect. Yung 3, yung pathologic. In the same manner, class, kunyari, meron kayong variable niyan, year level. Tapos 1, 2, 3, 4 yun. Okay, 1, 2, 3, 4. You can use that as a factor. But in R, we have to convert this into a factor kasi ano siya integer siya. No? So let's do that. Let's convert. Natin dito, convert. Again, yun lang yung notes, guys. Convert si cardio $NSP to a factor to be used as a classifier. So classifier siya, no? Hindi siya pa pwedeng integer. Okay? So how do we now convert it? Control Alt I. So very easy to convert in R. No? So i-name lang natin cardio dollar. Babalik na lang tayo sa N. Yan, NSP. And then Alt minus. So what are we doing? Ang sinasabi natin kay R, yung cardio na object na data, tapos yung in particular yung NSP, which is already existing, may gagawin tayo dyan. Okay? So, sabi natin, ang function ng as that factor. Okay? So, as that factor. And then, ano yung gagawin natin as that factor? Si cardio, dollar, NSP. Yun lang. Okay? So, by doing this, we're going now to convert yung sa cardio data natin, yung NSP variable, it will now be converted as a factor. Okay? And anong pangalan ng object na yun? Yung pa rin. No? So, ibig sabihin yung data natin na cardio, okay? Currently, ito yung cardio natin. When we write this code, ano mangyayari? Masusuperimpose na tong cardio na data na to. So, yung cardio natin na data na to, mapapalitan na yung NSP dyan, magiging factor na siya. So, let's run this. Okay. Now, how do we check? Guys, let's check kung ano na siya. Kung kanina, di ba, dito na check natin. Let's see, class cardio dollar to access the variable NSP. Okay. Let's see if it's still integer. Okay. And then what do you see? Class. And then sabi lang sa akin kung nakahabol kayo. Kung so factor na din ba siya? Okay, good.
Yes, sir.
Factor, sir.
Alright. So with that, pwede na nating magamit si factor as a classifier. Otherwise, guys, kung hindi natin ginamit siya, it will be treated as a number. Tapos magkakaroon ng issues as far as paano kung yung value na makuha is, let's say, 2.35, ganun. So saan siya saan siya i-classify? Okay? So that will solve a lot of problem, and hindi ko na muna i-explain yung nitty-gritty details kasi sa computation yan. No? But tingnan din natin yung structure, and then structure ni cardio. So let's see. Alright. You can see here, sa ilalim, yan, si NSP. Di ba kanina yung si cardio, si NSP, integer yan. Ngayon, factor na siya. And sabi pa nga, with 3 levels. Yung levels here means in classification. 3 classification. Si 1, si 2, at saka si 3. Huh? Check ko lang Let me see if I recall table cardio NSP. Just to check. Ayan, okay. Okay, here we can see the count, no? Using the table function. Ayan. Ilan yung 1, ilan yung 2, at saka ilan yung 3. Okay. All right. Any questions so far? Medyo nakikita natin kung ano yung distribution ng data natin. Ano? There were 1655 of the 2,000 plus observations. 1655 belong to class 1, 295 belong to class 2, and then 176 belongs to class 3. All right. Questions so far, guys? As far as
Answer.
good. Okay, sige. Ngayon, sa machine learning, okay, unlike dati siguro yung regression nyo sa whatever subject you did that, anong ginawa nyo dun sa data nyo? Yung buong data nyo ba, renegress nyo? whether you use Statistica or SAS or SPSS, gumawa ba kayo ng tinatawag natin data partitioning? Kung wala kayong ma-recall, baka hindi nyo ginawa, no? Kasi yung data partitioning, sa machine learning na lang in-introduce yan. Did you, class?
Wala po, sir.
Wala. Okay, sige, good.
Wala po ma-recall.
Sige. Pag walang ma-recall, ibig sabihin, hindi na discussion. O hindi talaga diniscuss kasi usually hindi naman sinasama talaga. But here, so siguro later on, pag mag-regression ulit kayo, you can do this. No? Huwag nyo lahat i-regress. I-partition nyo yung data into what we call a training data, and a testing data. So anong ginagawa nito? Usually dalawa, minsan meron pang isa, no? Isang group. What we do is that the data set, we're not going to use all the respondents, all of it, para kunin yung model natin. What we're going to do is we're going to split the data, okay, by a certain proportion, certain percentage, usually 70-30, 80-20, depende dun sa laki ng data natin. So, ang gagawin natin, we are going to partition our data. So, the bigger data that we're going to model, and then the remaining data, iti-test natin. Whatever model we were able to generate, we're going to run our testing data in that model and see if it can also model yung data na hindi pa niya nakikita. Okay? What do I mean by na hindi pa niya nakikita? Kasi remember that we're going to split the data. Okay, let's say 80-20, 80%, 20%. Yung 80%, gagamitin natin yon para i-model yung hanapin natin yung model natin. Whether it's a decision tree, or XGBoost, or whatever model, whatever supervised learning model. And then, once we get the model, we will now test our training data. Doon natin i-run. Tapos tingnan natin kung maganda ba yung output. No? If it's a good output, ibig sabihin, robust yung model natin. So why don't we use everything? Okay? Kasi, pag ginamit natin lahat ng data natin, magkakaroon tayo ng a problem called overfitting. Ano yung overfitting? Ginamit natin lahat ng data natin, so R will attempt to try to come up with a model for that whole set of data. Now, if we're going to use that for another set, baka hindi na mag-work well. So we'll just split our data. One will call training data, another will call testing data. Run our model, take a look at the results, see if our model did well dun sa training data, and then run it now for your testing data. Okay? Clear ba yung concept, guys? Clear so far?
Yes po, sir.
Okay, sige. So, isplitan natin data natin, no? So, lagyan natin dito. Partition the cardio data set into 2, ba? Para sa training natin. Training and testing data set. Okay. In R, okay, magra-random yan, randomly ipapartition yung data set. So, pag ganun, pag randomize yan, magiging magkakaiba yung data set natin, di ba? Kasi random yan eh. You agree, guys? Kung it will be run randomly, yung iraran nyo dun sa equipment nyo, at saka pag rinan ko yan sa equipment ko dito, since randomize yan, iba-iba yung mapupunta sa training natin, iba-iba yung mapupunta sa testing data natin. So hindi tayo magkakaroon ng uniform na we cannot compare kasi magiging iba yung data set natin. Do you get me, class? Paki-yes naman o ano? You need me to repeat?
Yes, clear po.
Repeat or yes, clear?
Clear po.
Clear po.
Sige, thank you. Kasi paano i-split yan? Ilan ba yung ano? Ilan ba yung 2,126, okay? Now, it will not be good if kunyari yung first 80% dun sa training at saka yung second 20% nasa testing. Okay, hindi maganda yon. Bakit? We don't know how the data was arranged. Baka arranged to alphabetically or arranged to by a certain area. Kunyari Manila muna, tapos Makati, etc., etc. So that will not be a good way to randomize or to split your data. Okay, kung by number lang, kunyari, if this was 2,000, example lang para mas mabilis yung computation, 2,000 and then I'm going to use 80% for our training. So 80% ng 2,000, that's 1,600. So the first 1,600, gagawin kong training data set. And then the last 400, the last 1,600, the last 400, gagawin kong testing data set. That's not good, no? Hindi natin alam kasi kung paano in-arrange yung data. Okay, so malay mo naka-ano pala to, naka-sort from highest to lowest ng a particular variable. So the best way to do this is to make sure that when the data is split into two, randomize din yung pag-split ng data natin. Okay, so in order for us to have the same type of randomization, R has this function set.seed, no? Random number generator. Yan, you can see. RNG siya, random number generator. And then if we have the same number, so pareho yung yung randomization na mangyayari. So let's make it set.seed 1, 2, 3, 4. It can be any arbitrary number. So set.seed 1, 2, 3, 4 kayo, set.seed 1, 2, 3, 4 ako, then we'll have the same. We'll have the same splitting of the data. Okay? Guys, clear ba tayo?
Yes po, sir.
Okay, sige. Tapos isama natin dito. Alright, dito muna, tingnan muna natin yung sample. We're going to make use of this sample function. Okay. Ito guys, let's see what, from base R to, no? Alright, from the base package sample. So what does the sample, sample takes a sample of the specified size from the elements of X using either with or without replacement. Okay, from your stat, I'm sure you met yung with or without replacement. Yung with replacement, ibig sabihin nun, pag nakakuha ng, kunyari, sa tambiolo ng mga numbers, kukuha ng isang number doon. Yung with replacement, okay, ibabalik yung number. Yung without replacement, pagkakuha, hindi na ibabalik. Okay, so ang syntax nito, ito, no? Sample X is our vector. Ito yung cardio natin. Okay, and then size, no? Size, anong size? And then replace is equal to true or false, and then yung probability, a vector or probability weights for obtaining the elements of vector being sampled. All right? So simple lang. So let's do this. So let's create an object. I'm going to let's call it PD, partition data na lang, parang sinortcut ko lang. Okay, gagamitin natin si sample function. And then may IntelliSense si R. Diba? Sasabihin sa atin kung ano yung laman ng function na yan. Alright. So X natin, ilan ba? Ilang samples ang gagawin natin? 2, di ba? Kasi isang training dataset at saka isang testing dataset. Okay. Now, ang next dito, ilan yung size? Ilan yung size? So yung size natin, yung number of respondents natin, which is 2126. Okay? I don't want to type 2126 here. Okay? We can use a function also for you to know this function, nrow ng cardio. Okay? All right. Nrow, sulat ko siya dito, no? Tells us ilang rows nrow ng object na to. Diba? Okay. Nrow cardio. So we know it's 2126. All right? So as much as possible, wag tayo maglalagay ng absolutes dito sa function. Okay? We can use a function itself, no? So nrow, that's a function. Okay. And then, so sige, gawin natin replace is equal to true. And then yung probability. Ano yung probability na ano natin? So probability is equal to, yan, no? Yung syntax, prob is equal to, so C, 0.8 and 0.2. Right. 80%, 20%. 80% yung pupunta sa unang sample, 20% yung pupunta sa pangalawang sample. Usually, guys, mas malaki yung training data set natin. So, yung iba ginagamit 60-40, 65-35, arbitrary naman siya, 80-20. So far, ang mga nakikita ko hanggang 80-20. Once may nakita ako 90-10, pero napakalaki ng data set na yun. So, depende sa size ng data set. Kung maliit lang data set natin, can use a lower, maybe 70-30 or minsan 60-40 pa nga. No? Alright. So, I'll let you first copy that or write that if you haven't written that. And then isama na rin natin, i-view natin kung ano yung result na to ni PD. Okay. If we're ready, any questions so far? Class? None. Okay. Sige. So ito guys, what will this do? Ipapareho niya yung randomized na sample natin. Okay? Which is good kasi para mako-compare natin kung pare-pareho yung results natin. Alright, so we're creating this object PD. Of course, arbitrary naman yung pangalan na yan. Ginawa ka lang parang partition data. 2, pwede nating split yan into 3, 4, 5. So depende dito sa ano and depende dito sa X natin. So here, dalawa lang kailangan natin. And ano ba yung size? Yung number of rows ni cardio. Replace with replacement to. And then the proportion is 80%, 20%. So let's run everything. Run. Okay. So what do we have now? We have this object called PD. No? Anong ginawa ni PD? Anong ginawa ni R? So it's an integer. Okay, pag check natin yung class, for example, class, kasi di ba may PD na tayo. No? Ayan, no? Integer, makikita natin. So it's class ni PD. PD. That should be an integer. All right? Tapos i-view natin siya. No? Asan ba si PD ko? Na-view ko ba? I-view ko na lang ulit. View PD. Okay. Click ko to. Sa inyo guys, nagge-generate ba ng ano? Hindi sa akin, ito yung dating problem ko sa R.
Same po tayo.
Same kayo?
Ganun
Ganyan
po
din
lumabas.
po yung lumalabas, sir.
Okay, sige. Ganito na lang. Ayaw niya ilagay sa spreadsheet Di wag. Dito na gawin natin. Print na lang natin. PD. Yan. So this is PD now. Okay. Ano si PD? Diba dalawang samples, no? Dalawang groups. Kung tatlo yan, 1, 2, 3, 1, 2, 3, etc. etc. So notice, pare-pareho dapat tayo, no? 1, 1, 1, 1. Ibig sabihin, yung first 5 respondents, ito, respondent 1, 2, 3, 4, 5, they all belong to group number 1. Okay, doon sila papasok sa training data. Okay? And then si respondent 1, 2, 3, 4, si respondent 5, and then this is whatever respondent this is. And then ito, lahat ng 2 doon sila papasok sa testing data. Lahat ng 1 doon sila papasok kay training data. Alright? Okay, pause muna ako. Allow you to look at our output. And questions, if any?
Sir, anong ibig sabihin ng mga 135 dun sa leftmost?
Okay. Yung ito, index number lang yan. Okay. So, ibig sabihin nito, ito pang 33rd observation na to. Okay? Ito pang, depende kung liitan ko yung ano ko. Ay, hindi, fix siya, siya. Fix siya. Okay. Kim, ikaw ba yan?
Yes po, sir.
Okay. So, gets yung ano, yung explanation?
Ibig sabihin po, yung
ito,
observation 1, kunwari, yung
ito,
column.
1, ito yun.
Opo.
Ito, pang number 33 to.
Okay po.
Dun sa list natin, di ba, ito yung cardio natin. May index tayo dito, di ba? Yan. Ito okay. 33. Ito, si 33rd observation. So si 33rd observation, saan siya napunta? Napunta siya kay group 1. Di ba ang ginawa ni R dito, nag-randomize siya, no?
Oh.
In-split niya yung mga data natin. Yung iba pupunta kay group 1, gagawin natin yung training data set. Yung iba napunta kay group 2, gagawin natin siyang testing data set. Alright? So this is just the index. This is observation number 161. This is observation number 257. Clear?
Clear.
Okay? Sige. Alright. So ito 993, no? Ito. Tapos sabi niya, kasi ang print out lang ni R is a maximum of 1,000. Kaya sabi niya, reach get option. Okay? Inumit niya yung 1,126 entries. Okay? 1,000 lang to. Ito, observation number 1,000. And there are still 1,126 na hindi niya pinakita. Kasi limited lang yung pinapakita niya. Okay?
Kaya po pinutol-putol na lang niya na instead na 1, 2, 3, ginawa niya pa-vertical yung view.
Hindi, horizontal Wait. What do you...
Horizontal.
Ito, horizontal yung pagsulat niya, di ba?
Opo. Horizontal po.
Yeah, ito observation 1, observation 2, 3, 4. Ito observation 33 to. Tapos ini-index niya dito. Si 34, yan ang ito, yung itong ano na to, that's the 34th observation. And si observation number 34, which is yung pinakita ko sa inyo kanina, ito yun, ano? 34 ba? 34 ba?
34.
34 pala, sorry. 34. No? Si observation number 34. Ito siya. So, napunta siya kay group 1. Okay, yun lang ibig sabihin nun. Kung saan mapupunta yung mga respondents natin.
Okay po. Gets.
Okay.
Thank you po.
Alright, good. Alright, so, since nakadalawang grupo na siya, no, split na natin siya. We'll now create 2 objects. Yung isa, train, yung isa, test. Okay? So, here I'm going to create a new object, train. You can name it any way you want, pero syempre mas instructive, mas intuitive yung pangalan na train to denote training data set. And then, gagamitin natin si cardio. Isa subset natin. Okay? Take a look at that, guys. Cardio. Yung brackets na ganyan, it means isa subset mo siya. So, i-define natin yung row number at saka yung column number. Okay, si cardio natin, ito, no? Ito si cardio. So, it has several columns, 22 columns. and it has 2,126 2,126 rows. So gusto natin mag-create ngayon ng training dataset na ang laman ng training dataset natin, lahat na naging 1 to. Diba, nag-create tayo ng PD na object. So may mga observations na 1, may mga observations na 2. So ang gagawin natin, ipagsasama-sama lang natin lahat ng observation na binigyan natin ng PD value na 1. Okay? So paano natin gagawin yon? So si cardio, sasabihin natin na ang PD na dapat, as far as the row is concerned, PD niya is equal to, okay, the double equal to yan, 1, and then ang column niya, lahat ng column. Okay, take a look at this, guys. What's happening here? So we're creating this object train. Si train will be coming from cardio. Brackets, no? Ibig sabihin, isa subset natin. And then dalawang brackets dyan, dalawa yung element, row and column. So, ano yung papasok sa row? Ano yung papasok sa column? Take note sa column, wala akong linagay. Ibig sabihin, kasama lahat ng columns. Okay, so, lahat ng 22 columns yan, kasama yan dun sa object na train na ginagawa natin. It will be part of the train dataset. I'm not putting any number here. Or if you want, lagay nyo 1 to 22. Okay? So that will denote column 1 up to 22. Okay? Kasi pwede natin i-define kung anong column ang pwede natin ipasok. So either that or just leave it blank. Ibig sabihin, it will be automatically read as everything. And then ito, yung row will be, sabi natin, lahat ng ng PD is equal to 1. Okay? Yung mga rows, okay, di ba, ito guys yung PD, di ba row number siya? Row 1, 2, 3, 4, hanggang row 2, 1, 2, 6 yan. Okay? So lahat ng 1 dyan, dito kay PD, row numbers yun. Okay? So, okay. I-run na rin natin si test. Test will be cardio pa rin, cardio. And then, again, PD. So that PD is equal to lahat ng number 2. Then lahat ng columns natin. Row, column. Row, column. Alright. Sige, pause muna ako. And try to see if you understand the syntax. And then, kung okay na ako, naintindihan, paki-yes na lang. Paki-unmute na lang. Para mabilis tayo. Okay ba so far?
Okay.
Okay, sir.
Okay, good. So ito yung pag-ano natin ng create ng object na train. So we will be expecting na magkakaroon ng train dataset dito. Ngayon, wala pang train dataset dito. Letter T, wala. Okay, pag i-run ko to, let me run this too. Yan, my train and my testing data na. Now take note, si train dataset, 1718 observations. Hindi na to yung 2126, no? Okay, i-view natin to. I'll write it here, view, train. All right. So take a look at this, si train dataset. Andyan pa lahat ng mga, okay, andyan lahat ng mga variables natin from pounds, okay, up to NSP. Tingnan nga natin, check natin na ncol, number of columns ni train. It should be, yan, 22, no? And then nrow ni train. Ilang rows si train dataset natin? 1718, right? So, ibig sabihin, ini-split niya to, no? Tingnan nyo. Yung index dito, 1, 2, 3, 4, wala si number 5. Diba? Right? Wala si number 14. Okay? Kanina, nung pinaprint natin si PD, diba? O, yung ano lang, let's say head, PD, yung first 20. Okay, ito si PD. Okay, first 20, head, ibig sabihin yung first few rows lang, first few elements, PD. Enter. Yan, tingnan nyo, class. First, second, third, fourth, fifth. Si fifth hindi kasama kay number 1. Tapos fifth, 6, 7, 8, 9, 10, 11, 12, 13, 14. Si 14 at saka si 16, kasama siya kay number 2. If we take a look at train data set, okay, wala si 14, wala si 16. So, tama talaga. Tama yung na-generate na train data set. And then, let's see the test data set. And, di ba? 5, 14, 16, 26. 408 entries. Okay? Now, hindi exact yung ano, no? Okay, 2126 na natin. 2126 times 0.8. Ay, sorry. Ilang bang observations dapat yung 80% ng 2126? 1,700. So, hindi siya exact. No? There's a way, if you want really an exact way, there's a way to do it. Pero wag na muna ngayon. No? Ang objective natin yung decision tree. Alright, any questions so far? Na-split na natin yung data set natin. Okay?
Sir, question lang po. Paano
Sige.
pag time series na po yung data?
Okay.
Para-
Pag time series, it doesn't make sense to split it. No? If ever
Oh.
you split it, chronological. Kunyari yung
Oh.
first 10 years, and then yung susunod yung, hindi siya pa pwedeng random. Kasi may chronological
Okay.
ordering yan, di ba? It
Okay.
doesn't make sense to January 1, tapos February 2, tapos June 15. Hindi siya logical to do that. Okay, this
Kung
is only used.
pag-randomize po, depende lang sa dataset kung
Yeah,
anong type of
pag
data.
cross-sectional data, okay yun. No?
Okay po.
But if you want to run sa quote-unquote randomize, kung gusto mo i-split yung time series, pwede. Pero paano gagawin mo? Kunyari, first 10 years, dun sa training. And then the last 2 years, iiwan mo siya. Yun ang
Or test
itetest
po.
mo. Oo, ganun.
Okay.
Okay? Alright.
Yes, sir.
So, yeah, good. Good question. Good question. Buti na lang na-raise mo yan, Kim. Si Kim ba yan? Si Leonard?
Kim po.
Kim, sorry. Okay. Alright. Okay, so good. So now, pwede na tayo magmo-model na tayo, no? Imo-model natin si train data set natin. Model natin siya, tapos i-check natin kung gaano kaganda yung model natin. Tapos i-run natin model natin para kay test naman. Okay? All right. Sige. So, Control Alt I. We will be needing the party package. So, mag-install tayo ng package. Install that package. Yes. Okay. So, party. Okay. So, paki-run to guys. Party pero partition talaga yan yung Okay. Yung mga dependencies siya. No? So automatically yung mga packages na kailangan linode na rin ni R. Okay, so we're done. Na-install niyo na, class?
Installing pa, sir.
Installing pa, sige. So, while we're installing, pupunta ako sa packages dito. I-write ko si party. Party, tinalang muna natin. Yan, party, So, you can require this instead of typing library. Kasi pareho lang tong pag-type ng library dito. Party. Lagyan ko lang to ng okay. Or clicking it here. Pareho lang siya. a laboratory for recursive partitioning. No? And pagpapartition ng data. Okay, if you're done, guys, inform me please. Ready na-install na?
Done na po yung sa akin.
Okay. Kay Kim, kay Leonard, install.
Okay na po, sir.
Okay. Leonard, na-install mo na?
Yes, sir.
Okay. All right. So, you can either run library or you can click it here. No? So that these are two ways to load your data. Pwedeng yung functional library or pwedeng dito sa plots, files, plots, packages pane. And then if I click this, gusto ko lang makita yung yung what this package is all about. It's always a good practice class to when you're meeting a particular package for the first time, konting konting kaalaman about that. So dito may user guides. Okay, and these are the functionalities. Binary tree class, random forest, okay, which is siguro inject ko rin to, no, kasi but maybe not yet next week. At least sa kapag simula tayo ng machine learning using decision tree. Random forest is another tool. Mas powerful siya kaysa kay decision tree actually. So titingnan din natin yan. Tsaka extreme gradient boost, XGBoost. So there are several methods that can be used in machine learning. So we're just scratching the surface. So we're using this party kasi meron ditong kunyari itong C3. This is the function that we're going to use. If I click this C3, so it will now do recursive, yung paulit-ulit partitioning for continuous censored ordered nominal multivariate response variable in a conditional inference framework. So ang gagawin niya, ipapartition yung data natin, no? Partition data until tatlo na lang lumabas sa ilalim. Yung tatlong yun, either N, S, or P. No? Okay, so ira-random niya yan. Hahanap siya ng algorithm na siya yung siya yung hahanap kung anong classification ng mga data natin sa training data. Alright, so ito yung syntax formula, yung data natin. Okay, kung may kailangan na weights, tapos may criterion pa dito, no? Okay, we'll explore that later. Alright. So, Control Alt I. Okay. Gawa na tayong ang unang decision natin. Decision tree natin. This will be our first decision tree using the party package. So let's use it. Let's call it 3.1 or 3.1. Sige, 3.1 na lang. And then we're going to use C3. Ito. So what's this function all about? So this is okay, sa taas. So it's conditional inference trees. Okay. So ito yung niya, yung details niya. It estimates a regression relationship by binary recursive partitioning in a conditional inference framework. So this describes the algorithm and then some details about the syntax. Okay, may sinasabi siya dito na test that type, Monte Carlo, Bonferrini, etc. But we will not go into so much details. Ito, minimum criterion, gagamitin natin to. Minimum criterion, for example, when minimum criterion is equal to 0.95, the p-value must be smaller than 0.05 in order to split this node. So, itong rule na to ginagamit para i-split na yung node kung ihiwalay niya. No? Okay, let's first take a look at the model para may idea tayo. No? So, gagamitin natin si C3. Yan. Okay. Ano yung natin? Okay, si NSP Si NSP yung regressor natin, yung dependent variable natin. And then ang regression sa R, we use shift yung tilde. And this means yan ang ginagamit na sa regression. So this is your dependent variable and the rest will be your independent variable. Okay, just to simplify muna yung natin, gamitin muna natin yung kahit yung first three lang na categories. No? For our purposes, of course, you can use all the other categories except yung mga yung mga summary statistics, yung mga descriptive stuff. Okay, for our purposes, we'll just take a look at the three variables that we will use as regressors. Oops. Nasaan na siya? Ito. Okay. Alright. So, lagay ko lang dito names para tama yung spelling ko, cardio. So, dito, inano ko lang yung mga variable names ni cardio. So, una si LB. Hanggang copyin ko lang to, Control C, Control V. So, tanggalin ko to, plus. Sama yung number. Okay, and then data is equal to hindi cardio, train na pala. No? Okay. Alright, ito yung magiging unang model natin and we're modeling NSP. Okay, and we're just using the first three variables. Of course, siguro mas maganda kung gamitin natin other variables, but just for the purposes of illustrating what will happen in this model, then I leave you guys to also look at the maybe include the other variables. Okay, so let's run this. Okay, so my tree object na tayo dito. Take note the tree object is a large binary tree. 1.3 megabytes nga. No? If I click this, ano laman? So marami siyang laman. No? Ito. So it's a list. It's a list of different objects. So andito yung data natin. If I click this, yan. So environment. So iba-ibang laman ng data ng data na list. Responses. Okay, so you have a lot of tree. Okay. Excuse me. So you have a lot of objects there dun sa tree object result na to. So let's just print lang natin, no? Print 3.1. Okay, so it will tell us. Okay. So this is now the conditional inference tree. Tapos ang sabi niya, 10 daw yung terminal nodes. Okay. 10 terminal nodes. Yan. Kaya hindi masyadong apparent dito. No? Yung 10 terminal nodes na to. There are 19 nodes all in all. But of the 19, 10 dyan yung terminal. Okay? Saan po yung terminal dyan? Paano natin malalaman kung terminal node? May asterisk. Okay, ito. 4 asterisk, 5 asterisk, 6. If we count those with asterisk, 10, 11, 12, 14, 17, 18, 19. They are your terminal nodes. Ano yung terminal nodes? What's your terminal node? Yung terminal node sa decision tree, no? Sa decision tree, siya yung nasa pinakadulo. Ibig sabihin wala nang kasunod yung node na yan. And we're going to show that here. Okay? So this tells us paano ini-split yung data. Okay. So let's just take a look at the the first one so that we understand what this is. So response variable natin NSP, inputs natin ALB, AC, FM, yung first 3 variables, and then number of observations 1718. So anong objective natin? Our objective is to be able to come up with a decision tree where you're splitting your data in such a way that we will predict or we will model kung si observation 1, ano siya? N ba siya? S o P? Si observation 2, N ba siya o S o P based on our decision tree. Okay? Mayroong actual na value, yung NSP. Meron ding model value natin. And then later on, we're going to compare, okay, how our model fared as far as predicting whether a respondent would be classified as an N, or S, or a P. So dito sabi, sa node 1 na to, if AC daw is less than or equal to this amount, okay, criterion 1 muna siya. Tapos, pag si LB, less than 136, criterion 1. If FM is less than or equal to 0.111898, criterion 1 din siya. Okay? Tapos may terminal node na tayo dito. Alright, so medyo mahirap siya intindihin dito. Okay, but let's first do the plot para makita natin kung ano nangyayari, no? Alright, so let me go here. Control Alt I. So let's now plot the tree. Excuse me. So how do we plot this tree? Plot na natin si 3.1. Okay. All right. Okay, so this is now the decision tree. Okay, medyo hindi siya kita, no? Natin. Yan. Okay. So let's take a look at this. Okay. So yung nasa dulo, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ito yung 10 na terminal nodes yung sinasabi ni C3. No? Okay. So how do you arrive at this? Okay, you start with this one. If AC is less than 0.001, okay, if it's less than 0.001, titinan daw yung LB. Okay, so if AB is less than, LB is less than 0.001, pupunta ka ngayon kay FM. If FM is less than 0.001, then we have this. No? Sorry guys. Hindi. 0.001. Wait, nandito ako. Oo, tama. Let's go back to the, check ko lang, Yan, tama. If AC is less than 0.001. So, naka-ano siya, naka-round off lang. So, that's the decision rule. Kaya nga ang tawag dito decision tree. This is called decision tree because you keep on branching out and it's tree-like, di ba? So, ano yan? It looks like a tree. So, yung sinabi nga natin na AC less than 0.001, punta tayo kay LB. Tinan si LB. LB is less than 0.001. Okay? Pupunta kay FM. But if LB is greater than 0.001, ito na siya. Okay? Node 6 na siya. Tapos kay node 6, may makikita tayong probability distribution. Yung black dito, probability na 1 siya. Yung gray, dark gray, probability na 2 siya. Yung light gray, probability na 3 siya. So, pag pupunta sa node 6, ang prediction is that it is, number 2, is suspect. Yun. Kasi makikita natin ito, mga probability distribution siya, no? And it will tell you kung ang probability niya is if it's 1 or 2 or 3. So, probabilistic to, class. Hindi siya deterministic. Alright. So, that's how the tree is interpreted. Ito naman, if AC is greater than 0.001, dito tayo. Yun yun, no? Less than 0.001. Okay? Punta ka kay AC ngayon. So, node 7 to. Right? And then, if AC is, medyo nalito ako dito. Nakulak ulit yung plot. Kasi dalaw dito eh. Okay, I think this is, sorry guys, this is the p-value. So, dapat, I stand corrected, plus, sorry. These are the p-values. So, dapat ito yung tinitingnan natin. Sorry, kasi matagal ko na rin itong hindi na gamit tong decision tree na to. No? Alright, so this is the decision. If AC is less than or equal to 0.001, punta tayo kay LB. If LB is less than or equal to 136, punta ka kay FM. Okay? Kasi, you know why I made a mistake? Kasi yung LB, asan si LB? Kasi si LB, let's take a look at the data. Hindi naman 0.001 yan eh, di ba? Si LB is 132, 120, etc. Yung weight yan. Weight in pounds. So, okay. Sorry guys mali yung paggamit ko kanina. Ito yung gagamitin natin na parameter. If AC is less than 0.001, then you go to LB. If LB now is less than 136, you go to FM. If FM is less than or equal to 0.112, then node number 4 siya. Pag node number 4, ibig sabihin nun, malaking probability na N siya, normal siya. Okay? So you just follow the branches and then it will lead you to a particular prediction. Okay, so dito sa node 5, kita natin guys, na halos 100% na pathologic to. Okay, itong branch na to, itong node na to. So if AC is less than 0.001 and if LB is less than 136 and if FM is greater than 0.112, there's a almost 100%. Yung 1 na to, probability yan, di ba? There's almost 100% na si respondent, mga respondents sa to are pathologic. Yan. Makikita na dito, mas malaking probability na suspect siya. For the rest, lahat normal. That's understandable kasi maraming normal, di ba? Doon sa cross tabulation natin, di ba yung table natin, 1,000 plus yung normal. Right? Okay, pakita ko ulit na just to remind everyone. Okay, mas marami yung may findings sa normal eh dito. Where is that? Ay, hindi ko sinulat dito. I should have written it here. Ito. Ito na nga lang. Ito pala. So 1655 out of 17 something. 1718 ba? 1718. Okay. So a big chunk. Ito yung end row ni ano? End row ni train. 1718. Actually, pwede nating gawing proportion pero di ba lang? Ano na lang, I'll just manualize it. 1655 divided by 1718. No? So around 96% normal. Konti lang yung suspect at saka yung dun sa table natin, sa train, no? Sa data natin na train. Alright. So balik ako dito. Okay, so what does this tell us, guys? Ito. Sa node number 4, so ang answer dito, ano siya, normal. 405 ang andi dito. Sa node 5, 11 na pathologic. Sa node 6, 314 yung predicted to be S, suspect. Ito 103, normal, 7 normal dito, 78 normal, normal. So yung mas malaki na ano na sa probabilistic distribution dito, siya yung magdo-dominate, no? So dito yung mga numbers na to, n is equal to 28, 12, mga normal lahat yan. Okay. Okay, clear so far, class? Paki feedback.
Yes po, sir.
Okay. Alright, so that's our first experience, guys, ang decision tree, no? Okay, now, pwede natin i-ano pa, no? I-plot ulit natin to, but let's make it a bit simple. Okay, Control Alt I. So, plot natin si 3.1. Okay, and i-type natin, pwede naman natin gawing simple. Run this. Okay. So, ito yung function, no? Dinagdag lang natin yung type is equal to simple. Okay, there's still a way to balance this, pero let's not go there anymore. So, ito, class, instead of the plot kanina, ang binibigay sa atin yung mga figures na. Okay, so you take a look at this. Pareho pa rin. So dito, if AC is less than 0.001 and then LB is greater than 136, so it will go here, diba? So this is your node number 6. Yung mga gray yan, terminal node yan. Node number 4, 5, 6. May mga pangalan yung nodes, no? 10, 11, 12, 14, 17, 18, 19. So those are the different terminal nodes. And it gives us yung probability sila, no? 0.401, 0.497, 0.102. Okay, so here, classified as ano to? As S, no? 314 yung na-classify under this one, and then S ang ano sa kanila, classification. Kasi makikita natin probabilities. 0.722 versus 0.728, 278. Therefore, itong 18 na respondents na pumasok dito sa category na to, they are treated as normal. Normal din to. Okay?
Yes po, sir.
Okay, good. Okay, 10 yung ano, no? 10 yung terminal nodes natin. Pwede pa natin i-ano, that's one thing that's good with decision trees. No? Pwede nating i-tweak yung model natin. Pwede nating i-control yung number of nodes, ayaw ng 10. Pwede nating make it fewer number of nodes, o fewer number of terminal nodes. So mas parang lalawakan natin yung yung mga criterion natin for one respondent to enter a particular basket. Okay, kasi ito 10. So mas medyo, lalo na kunyari kung 20 terminal nodes yan. So mas mas refined yung yung mga classifications na pupunta dun sa mga branches. But it depends on how accurate you want your modeling to be. No? So depende din sa needs ng accuracy. All right, so let's do that. Prune natin yung tree, no? Prune the tree so that we can control for the number of nodes. Okay, so anong gagawin natin? Ano kaya pwede natin? Yung kanina dito, gawin natin, ang default kasi, dito, di ba? May nodes tayo dito. Let's use this. Kasi yung main criterion dito. Ito, no? Okay, dito, minimum criterion niya, 0.95. Okay, ibig sabihin, the p-value must be smaller than 0.05 in order to split this node. Okay, so what we can do is to adjust kunyari minimum criterion. Gawin naman natin let's see what will happen if we make it on the other hand 0.9. 90% natin. Lagyan natin dito. Sige, dito sa loob, no? In criterion natin, let's make it equal to 0.9. Ang default kasi 0.95. And then, so, dito kasi nag-i-split kahit ano eh. Ito, tingnan natin dito. Di ba dito may split na kahit maliliit lang, no? Kahit konti lang yung laman. So why don't we subukan natin na split only when the sample size at least is at least gawin natin may mga 12 dito, 7. Gawin muna natin 100 kunyari, no? So dapat mag-split lang siya kung yung natin yung sample size maging okay. Dito ako maglalagay ng sa labas sa ring comment para hindi masyado marami laman yung code chunk natin. All right, so let's create now another okay, 3 dot, gawin natin 1A. So gawin natin 3.2. Huh? And that's 1A kasi naka-base pa rin naman dun sa Isa, no? Okay, let's call it 3.1a. And then, ganun din, no? C3 yung function. Right? Copy na lang natin tong code natin dito. I'll copy the code here. Okay. Tapos, saan nga ba yun? Ano? Wait, ito, dito sa control siya. Okay, yung mga controls, ito. I normally don't memorize class unless laging ginagamit. I refer to the documentation. Mas madali, no? So ilalagay natin siya sa sa controls, no? Ito. So we're going to insert here. Okay. Controls natin. Controls natin is C3 pa rin. And then C3 control. C3 underscore control. Okay, so we're using this syntax. Okay, and then yung minimum criterion natin, ito, this one. Gawin nating 0.9. Okay, para hindi siya masyadong maraming splits ng ano. And then yung isa pa, okay, huwag dyan. Sorry. Yung main splits natin. Main split. So, ginawa natin 100, no? 100 lang. Check ko nga. 3.1a, same function, NSP, regression, LB, ECFM. Data natin is equal to train. Controls natin, C3 control, minimum criteria 0.9, minimum split at 100. Ibig sabihin, yung mga sizes ng splits natin, dapat hindi less than 100. So, ang magiging effect niya, mas liliit yung ano natin, no? Yung decision tree. Hindi siya magiging 10 terminal nodes. Kasi, nasabi natin na hindi pa pwedeng konti lang yung laman. Minimum of 100. Alright, so let's summon natin yung plot. Ayan natin. Okay, there. Hindi makita na. Split ko siya. So natin makita yung print natin. Okay, sineparate ko lang class yung plot. So let me print again. I want to see. Alright, ay, dumami yung terminal nodes natin. Naging 12. Okay, naging 12. Kasi yung minimum criteria natin naging 0.9. Okay, so dumami. Alright, lilitan nga natin ito, gawin natin 200. Anyway, we're just parang nagtatry lang tayo. Yung mean split natin gawin natin 200. Kasi ang naging effect nito, although ginawa natin itong 100, ito naman yung 0.9, medyo linawakan natin yung p-value. So let's see this. Run natin to. Ayan, nabawasan ano. 0.9. If I made this 0.95, yung pareho ng default, mas liliit yata to. Let's see. O, 8 nga. 8 na lang. Kasi kanina, 0.95 tayo. Yun ang default. Tapos ginawa akong 0.9, dadami yung ano nun, no? Dadami. Kasi mas lumalaki yung p-value, mas maraming pwedeng pumasok dun sa in other words, pwedeng pumasok dun sa split natin. Okay, so here we have this scenario. Gawin natin 0.9, ano, kasi nakalagay dito. At least bumaba naman to. Okay, there you have 9 terminal nodes. Lumiit, no? And then i-plot nga natin. Okay. So, gawin na lang natin para mas madali makita yung okay. Let's just copy this, yung type. Okay. So, wait. Okay, hindi niya lahat nasusunod, ano? Yung mean split.
Sir, parang yung min split, ano lang
Yung
siya.
ano?
Siya yung minimum. So, pwede siyang
Ay, o nga pala. Sorry. Mean split minimum siya.
hindi po ata
Oo,
pinag-control.
tama. Wait, 144, 170. Okay, check natin, 405, 11. So, pwede mag-split. 144, 170, 300. Okay. 188 to 18. 18. Okay. I think mean split, no? So, pwede lang siya mag-split kung dapat hindi pa pwedeng lower than 200. No? I think mali yung tinitingnan ko na to, no? Kasi yung split, it happens here. Okay? So, yung total nito, 405 at saka 11. When you sum, it's, at this point kasi, 416 yung, yung na-filter dito. No? Okay, so which is greater than 200. So, okay yun. Pag sinabing mean split, you can only split pag at least 200 yung respondents na ando dun sa category na yun. Here, 144, 170, ito yung total na filter dito. No? Right, guys? You got it? 314 yung na-filter dito. So, in-split siya into 144 and 170. Okay. Dito naman, it's 188, tapos may 18 pa, may 28. No? So, dito, 188 plus 18 plus 28. So, that's greater than 200. Kaya na-split siya. Diba? Tapos ito, since 18 na lang siya, hindi na siya mas-split. Okay? Hindi, sorry. 188 plus 18 plus 28 plus 742 plus 12. So, yung ano dito, yung total dito is more than 1,000 pa, no? So, pwede siya ma-split. Yung 188 na punta dito, okay? So, pagpunta dito ngayon, this is still 1,000 plus. So, 80 na punta dito, yung the rest na punta dito. So, pagpunta dito, more than 200 pa rin. Okay, you get me, guys? Kasi when we get here, the actual sample is 188 plus 18 plus 742 plus 12 at saka 28. Lahat ng mga yan, andi dito yung connected. Diba? So since more than 200 siya, ano siya, yung pwede pang ma-split dito. So 188 plus dito mga 1,000. 1,000 plus dito. Tapos dito napunta 18. So 1,000 plus pa rin to. Okay? Tapos napunta 28 dito. Tapos ito mga yan, ano lang daw? 800, 700 plus. And then finally. Okay? All right. So I hope that's clear, guys, yung mean split natin. Okay? That's what we sa decision tree, that's what's meant by mean split. Okay? So you can still look at other ways to modify the tree a bit. Pero yun ang I guess for our purpose, yun ang yung pinaka-importante. Okay. So let's all right. Any questions so far, class?
None so far.
In fact, paano kung gawin natin itong 300? Sample lang natin, ha. Let's make this, pag ginawa natin 300, so, ibig sabihin nun, mas kukonti yung pwedeng i-split, no? Kasi dapat, yung isang node, dapat more than 300 siya. Pag less than 300 na siya, hindi na siya pwede ma-split. But of course, the greater the less number of nodes, terminal nodes, the more inaccurate your model will become. Patin na lang natin to. Kung 300 siya, 9 to, gawin natin 0.95 to. Okay. So 8 na lang dito, no? 8 na lang. Kung dagdagan natin, kunyari to 400, I'm just experimenting on this. Okay. 8 na lang din. Kung 500, wala, konti na lang. 7 na lang. So the greater the mean split is, it means that you're only able to split your data, classify it more, if the size at that level of classification is more than 500, is 500 or more. Okay, so ibalik ko na lang sa 200. Okay, so
Sir, question pala.
yes.
Kapag blanco po yung test stat, ano po yung
Pag
default
blanco yung
na-
yung
Kasi po dun sa kapag tinatype po yung code, may lumalabas na test stat, yung mga Monte Carlo.
oo, sa ano yan?
Kapag blanco po yun,
Ang
ano po yung...
default?
Opo. Ano
Wait,
yung default?
let's see the default. Ito, no? Implementation utilizes a unified framework for conditional inference or permutation test developed by Strauss and Weber. Multiplicity adjusted p-values. Test type 1 Ferroni or test type on the univariate, okay, p-values. Okay, in both cases, hindi natin minention to, no? So, I'm not sure if this is the default. Kung nagbo-Bonferroni siya or Monte Carlo. We will have to dig deeper, no, and go to the documentation para malaman.
Sige po, napik ko lang.
O, ano natin, ha? Pag nakita mo, sabihin mo kami, ha? Kim?
Yes po.
Okay, sige. We can look at the documentation kasi doon dinalagay kung usually sinasabi na rin dito yun. One last check. No? Okay, saan ba natin dinalagay ito? Test type. Wala dito yung test type. Kasi baka nasa C control siya. May buckets pa nga, oh. Okay, so marami pang laman yung ano, yung, ito, you know, test stat. Ito yung C control. So under C3 control, doon natin malalagay yung type. Bonferroni, Monte Carlo, Univariate Test Statistic. Ngayon, hindi ko lang alam kung ano yung default niya. Okay. Test. Hindi siya naka-indicate. Okay, then we will have to check the documentation. Okay. Kim, wala siya dito. Hindi siya nakalagay. So we will have to check the documentation. Huh?
Okay po, sir. Thank you po.
Okay, sige. Thank you. Thank you for that question. Okay. So, all right. So may model na tayo, no? Dalawang models natin, either 3.1, yung 10 terminal nodes, o yung 3.1a, yung 9 terminal nodes. So we were able to generate 3.1a when we modified yung C3 controls, no? Okay. So next, ang gagawin natin, i-test natin kung okay ba yung model natin, no? So first, ipipredict natin. So what do you want to use? Yung 3.1a or 3.1? Sige, 3.1a na lang. Para 9 lang yung terminal nodes natin. Alright, so what we're going to do now is to predict. Papakita natin based on the predict values using 3.1a model. Okay, let's predict the values using the 3.1a model. So let's call this P1 na lang, P1P for the 3, no? Predict 1 dun sa 3. Okay, of course you can use other names. Sinisimplihan ko na lang. We can use the predict function. Okay, so the predict function is from the stats package. Okay, tingnan lang natin kung anong gagawin yan, ha? Kasi hindi naman tayo nag-regression sa subject na to, no? So let's just try to see what the predict function can do. So to check a function, tingnan natin, question mark, predict. So this is from the stats package. Yan, ito yung namesake niya. Ito yung function, predict, ito yung package. And predict is a generic function for predictions from the results of various model fitting functions. So medyo generic siya. No? Object is the model for which prediction is desired. So may model na tayo, di ba? Ang model natin, yung 3.1a. So gagamitin natin itong predict function. Okay, may mga examples dito. We will not run that. Alright, so ang predict function, ginagamit siya para i-predict based on a particular model, regression model or prediction model. So ang model natin is 3.1a, right? Okay, and then, oops, ano yung data na to? Saan galing na data to? Data that we use for that is yung train. So ibig sabihin, yung 3.1a model natin, gagamitin niya yon para i-predict yung train data set natin. Okay? Pero take note that we used the train data set to generate the 3.1a model. So ibig sabihin, gagamitin natin yung model na generate natin from the train data set to predict kung ano yung NSP natin. And then, so with that, pag na-generate natin itong P1P na to, mako-compare natin yung actual value ng train natin at saka ng P1P natin. Gets nyo? Class? Ulitin ko yung explanation, medyo circuitous yata. No? Si P1P will generate a vector, okay? A vector of predicted values. Okay? Kasi gagamitin natin si predict function using 3.1a model, and then ang ipe-predict niya yung trained dataset. So take note also that trained dataset has its actual values of NSP. May variable tayo ng NSP doon. Si P1P, ipe-predict niya, okay, si trained dataset, ipe-predict niya yung NSP using the 3.1a model. The 3.1a model, if you recall, predicts, okay, or regresses NSP on LB, AC, and FM. Kaya nga yung mga variables na ginamit dun sa 3, yung LB, AC, at saka FM lang. So let's run this. Run. Okay, and then i-ano natin, kunin lang natin yung head, yung una lang. Set. View na nga natin, tingnan natin. View. P1T. Okay, hindi siya nag-ano, no? All right. So P1T is a factor with 3 levels, 1, 2, 3. So dito na natin i-ano. Head na lang natin dito. Head ng P1T. Sabihin natin first 30 values. All right. There we go. Gawin natin first 100 values. And then first, sige, pwede na first 20. Okay. So side by side, tingnan natin Control Alt I. All right. I-head ko ulit to, head. And then P1T 30. Tingnan natin 30 values. Tapos i-head din natin head si cardio yung NSP and then 30 values. All right. So sa side by side natin, yung predicted value natin at saka si actual value natin. Let's see how they compare. All right. Two ba? Bakit two? Let's see. Si cardio. Ay, oh, tama. Okay. So what I did here, class, was to okay, balik ko yung ano, no? Ito yung actual natin, 2111333. Ito yung actual values ng NSP natin. Okay, so pinaprint ko siya, yun. Head ng cardio NSP 30. 211133322. Okay. And then let's take a look at the forecast. Yung unang forecast, 1. So mali kagad yung unang forecast natin. Ano? See guys, kino-compare ko Ito yung forecast, yung P1T. Ito yung actual. So second observation, 1-1 tama yung forecast. 1-1 tama, 1-1 tama, 1-1 tama. 1-3 mali, 1-3 mali, 1-3 mali, 1-3 mali, 2-3, 2-2, 2-1, 1-3. Okay, so you can see now that dun sa forecast natin, may mga mali. No? May mga errors tayo as compared to the actual. Okay, let me pause for a while and ask you if this is clear to you.
Clear po.
Okay, good. So we can see that there's a difference between the actual and the predicted values, no? Okay. Sige, so ang gagawin natin ngayon, tingnan natin kung ano yung misclassification. We'll generate a table for R to determine ano yung tamang na predict at saka ano yung maling na predict. So let's call it a misclassification error table for our trained data set. No? For the trained data set using the model 3.1a. You can, of course, check what if you use the 3.1 model. So it would be good to compare that. Kung sino mas maganda ba, yung 3.1 o sa 3.1a. Okay, so for our purposes, we're just using 3.1a. But of course, you can just replace this and use the 3.1 model. Okay, so gawa tayo ng table. We call it table. Just to be consistent with 3.1, gawin natin tab.1a. So this is para kung sakaling gagawa kayo dun sa 3.1, gawin nyo siyang tab.1 yung table. So gagamitin ulit natin si table function. Yan. Okay? So si table, all right. So on the row, ilalagay natin dito yung predict na ginamit natin, no? Ilalagay natin yung values na to. This one. So let me copy this. Control C. Okay. So ilalagay natin sa table yung value na na-generate natin from the predicted value ng 3.1a. Okay, at saka actually mali ako dito, guys. Sorry, mali ako dito. I-correct nga natin to kasi hindi cardio yung kino-compare natin. It should be your trained data set, no? Okay? Yung cardio yun yung original. Ang minodel natin kasi, di ba, yung train na, no? So dapat ang kino-compare natin yung model na na-create natin from 3.1a and yung data ng train dataset natin. So I stand corrected. Run ko to. Ayan. So ito na yung mas tamang comparison. Okay, I hope you got that. Okay, may mga mali pa rin, no? Okay, and now we're going to test kung ilan ba yung namali niya. And then this one, ito na yung ano, gagamitin natin yung galing kay train dataset, yung NSP. Okay? And lagyan natin ng pangalan to, no? Let's call this predicted value. Predicted. And then this is your actual. Okay, so what will happen here? Mag-recreate si R ng table. Okay, ang nasa rows, yung predicted values. Ang nasa columns, yung actual values. Okay? Of course, dito, yung predicted, pwede natin gawing ano to, no? So, gawin na lang natin P1T to. P1T. Okay, kasi baka malito kayo. Okay, di ba si P1T, yung object na yon, di ba? Si P1T, that's your predict. Diba? That's your predicted value. Okay, so predicted is equal to P1T, then actual is equal to yung trained data set natin, yung NSP niya. Okay, so take a look at this first and kung may questions kayo. Alright, so i-run natin to. So meron na tayong dapat tab.1a dito. It's an object. Ito. So it's a table. Alright, so i-print natin yung table natin. Okay, so print tab.1a. Okay, let's print this. Alright, yun. Okay, so ito yung nasa ano na to, nasa column sa to. Column 1, column 2, column 3. Ito yung actual values. Actual value na 1, actual value na 2, actual value na 3. Tapos ito naman yung mga predicted, no? Okay. Predicted 1, 2, and 3. All right. So now, predict siya na normal siya and actually normal siya. So tama to, di ba? 1, 2, 2, 2. Predict siya na 1 siya, normal, pero suspect pala siya. So this is wrong. Predicted siya na 1, pero pathologic pala siya. Turns out na pathologic siya, yung actual pathologic siya. So mali din to. So here, it's only the diagonals that are correct. Predict na 2, actual 2 siya. Predict na 3, actually 3 siya. Zero, no? Ibig sabihin dito, walang among the predicted na that was predicted na 3, walang predicted na 3, tapos wait na. Predict siya na 3, wala. Okay, so walang predict na 3 sa model natin, wala siyang predict na 3, walang napunta sa 3. Tama ba 'yun? Wala ba na predict na 3 sa ano natin? Sa 3.1a? Check ko lang class, Validate lang natin. Baka may something error ako dito. Okay, let me see this. Okay. Wala nga, guys. Kita nyo? Dito, ito, normal, no? Node 3. 1, 2, 3, 4, 5, 6, 7. Anong model to? Wait, sorry Tama ba yung model ko? 3.1a, no? Tama. Wala nga siyang predict na yung model natin, model.1a, walang na-predict na na pathologic. Sa node 3, pinakamalaki si normal, node 2 pinakamalaki si suspect. Ibig sabihin may mga na-predict na suspect, 3, 1, 4. Dito, normal, 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 normal. Okay? So you see what happens when we try to limit the number of nodes, no? Nagiging sorry, hindi ko na point out kanina to, no? So tama nga yung table natin. Walang na-predict na na pathologic. When in fact, alam natin na may mga 100 plus diba na pathologic based on the table na na-create natin. So this is the disadvantage of making your model decision tree so very simple by minimizing the number of terminal nodes, no? So there has to be a balance. Pangit naman yung masyadong complex na parang hindi na siya makatotohanan. And pangit naman yung siya masyadong konting nodes, right? In this case, 7 lang yung nodes nga, pero alam naman natin na hindi magiging magandang Hindi magiging magandang model kasi kukonti lang yung natin, kukonti lang yung nodes natin, 7 lang. Okay. All right. So siguro, class, okay, I'll leave you as an exercise to model yung 3.1 kasi dun sa 3.1, ayun, mas mas yung 3.1 natin, di ba? If I explode this, merong may pathologic yan. Ito. Dito sa node 5, may na-predict siya na pathologic. Okay, so mas realistic tong lumalabas dito kasi okay, may na-predict siya mga pathologic, and in fact, there are pathologic na patients, di ba? Right? So, but I leave that to you, no? Kasi pareho lang naman yung gagawin nyo. You're just going to change the model. Babaguhin nyo lang yung 3 nyo, 3.1. Alright. So, oo nga. Nagulat ako kasi bakit 0 yung na-predict niya na na pathologic. And true enough, 0 talaga. Okay. Alright. So, ito na yung natin, yung that's also called, may pangalan to ewan ko kung na-meet to dun sa so this is AKA, this is that's your confusion matrix, no? If you recall, kung na-meet na yan dun sa other subjects. Okay, of course, you can change the yung una dito will be on the ito yung nasa row, kasi ito yung nasa column. Okay, sige. Tingnan lang natin kung ano mangyayari kung baguhin lang natin order. I'll call it A1AA. And this one is, babaguhin ko lang yung order nito. Control X, Control D. So, pinalit ko lang yung nasa row ko, yung actual, yung nasa column ko, yung predicted. Okay? So, sometimes you might wish to do that. Okay? Ayan, ito yung actual natin. So, in-invert lang yung actual natin on the rows and predicted on the columns. Okay. So, let's compute now. Base lang to. Let's compute now the ilan yung percentage na na tama at saka ilang percentage na mali. So, how do we do that? Ibali, lang, no? Ano yung mga tama natin? Ito, 1222 plus 156 plus 0. Diba? Ilan yung lahat ng observations ng n-row ng train data set natin? There are 1,718 observations. So if we do the mathematical of this, 1222 plus 156, okay, kailangan lagyan ko ng parenthesis, divided by n-row, no? N-row ng train. That gives us 80.2% na accuracy. So we were able to correctly predict ilan yung N, ilan yung S, and ilan yung P, 80%. Of course, there's a better method for that. We can use a formula. Isum natin yung, so what will we sum up? Ang tawag dyan, guys, diagonal. So the sum of the diagonals of the table is tab.1a, right? This is the tab. Ito yung tab.1a natin. Diba? Tab 1a natin to. So sum of the diagonals. Okay. And then what do we divide it by with? Divided by the sum of tab.1a. Lahat. All right. The diagonals divided by the sum of the elements. So this is now the proportion of correct predictions right. And then siyempre kunin natin yung of misclassified observations. And we will just 1 minus lang. Yeah. Okay, so this is just 80% correct, 19.7% misclassified. Okay. Questions?
Is this hit ratio acceptable, sir? Or usually ano ba yung standard
Walang ano
practice?
walang ang ginagawa diyan, you use other models, no? Use other models, for example, gamit tayo ng at saka depende sa field. Imagine kung ano to sa medical field, no? Tapos mas kailangan na mas accurate yung yung prediction natin. Baka hindi acceptable to. Pero kung regular classification lang yan, kunyari, ginagamit natin data, whether a person based on other information about his, let's say, kung saang high school siya nanggaling, kung ano yung grade niya ng math, ano yung grade niya ng etc. And then we're going to predict kung matatanggap ba siya sa school or hindi. Parang ganun, parang classification problem na I'd like to classify whether this student having these attributes will be accepted or not. Yun, mas medyo lenient yung doon, yung rate kung acceptable or not. But in the medical field, as 19% na wrong, kunyari, ito, gagamitin to kung magkaka-cancer yung tao. Tapos, and then with that prediction, gagawa ng diagnosis, gagawa ng medication. 'Di ba? Parang ang laki ng error na 20% mali yung diagnosis. So it depends sa field. Okay? And also, it's also compared with other methods. No? So kunyari, aside from the decision tree na nakita natin ngayon, we can use another model called random forest and another model called XGBoost, which are more powerful, more robust than decision trees. So if we're going to base our modeling based on that, kunyari sa random forest, 92% versus 8%, then we can say that this is a not so good model kasi there are other methods that are able to predict better. Okay, so thank you for that question. And as I said, the answer there is it will really depend on several factors. Unang-una sa field ng ginagawa natin ng study. Some fields are really more exacting. Some fields are really more, let's say, strict. Okay, kaysa other fields. All right? Okay, so last, guys, tapusin lang natin to. Kasi, so far, ito yung nangyari sa natin. Very quick lang, tingnan natin kung sige. Tingnan natin, class, kung, let's see. What if we had used di ba yung naunang model natin, yung 10 decision trees siya, 10 terminal nodes. Okay. What if so let me call this, kamali ako, sana ginawa ko tong, okay, anyway, P1T na lang din that, sige, na lang, that one, pasensya na sa kaguluhan sa name. PT.1 predict, gamitin natin si 3.1. No? Alright. So we now have this object, yung predicted values natin using the 3.1 model. Kasi ang ginamit natin sa yung 3.1a. Okay? So, gawa tayo ngayon ng table. Copy ko na lang to, no? Control C. Gagawa ako ngayon ng table. May predicted na kasi tayo. Control V. I'll call it tab.1. Table. Predicted natin ito. PT.1. So, gagamitin ko yung predicted value natin using 3.1. So, this is all about 3.1. Compare using 3.1 model. 3.1 predicted is PT.1. Ito yun. Actual, yun pa rin, train data set natin. So, print natin si tab.1. Alright, this is now using the 3.1 model. No? Okay. Alright, so you can see here, ito yung lumabas na predict natin na 3. So, suspected siya na 3. So, dito tama tayo, no? Alright, so, let's now copy this. Para makita natin kung ilang percent yung tama. Control V. Alright, so this is tab 1, tab 1. So lahat tab 1 to. Okay, so let's see. Kung malaki ba yung difference ng .1a at yung .1. Alright, hindi naman masyado nagkalayo, no? 80.8 to, at 19.1. And then this one, 80.2. So, a bit better yung kanina, yung 10 yung terminal nodes. Okay? But not so much really. Didn't make so much of an impact. 81%, 19%. Okay, you got this, class? Sorry, medyo namadali na yata yung last ano ko. Let me flash that just in case you have questions about that. Bali, ano na lang yung inulit lang natin yung process using the 3.1 model. Yung unang model natin, yung 10 yung terminal nodes. Yung may prediction na may pathologic. Okay? Pero 11 lang naman yung na-predict na pathologic nun. Whereas, di ba yung table ng train, cardio, ilan ba yung NSP dun sa Okay, 144 yung pathologic. Ang na-predict natin 11 lang. So medyo mahina siya dun sa sa 3. Well, guys, by the way, let's not forget that we were just using 3 variables. Okay, lest we become so disappointed with the result. Ginamit lang natin yung tatlo. Yung LB, AC, FM. We could have used up to hanggang width, no? Okay. Of course, hindi na itong minimum maximum. Okay. And then maybe you could so mas magiging complex yung model natin pag ganun. Kasi mas marami ng factors na titingnan. Kanina tatlo lang. And I purposely did that kasi I just wanted us to have a taste of yung decision tree, machine learning tool na decision tree. Okay. And then yung last guys, ang gagawin natin, i-model, uulitin natin process, but this time, we will now, okay, babalik tayo dito sa, okay, Babalik tayo dito sa wait. Babalik tayo sa predict. Okay. Sa predict using this time yung test data natin. So let's do that very quickly. Okay, ito, no? Let me just copy this. Control C. Okay. Okay. So, gagamitin natin ngayon si test dataset, no? Para i-validate yung model natin. Alright, so we're now going to use 80.2 na tayo. Okay, 3.1 pa rin, and data natin will be this time test data na. No? Test data na. Okay, let's call this tab 2, table 2, and this is pt.2. Actual is equal to test. Alright, print 2. So gagamitin natin yung classification tree, yung 3.1 na model na yon, and we're going to use it on the data which is testing data. Okay, I hope you recall that in-split natin data natin so that hindi tayo magkakaroon ng overfitting dun sa model natin. And then we have now a data that we can use to test if okay ba yung model natin. Okay? Predict that 2 using 3.1 model, data is equal to test. Let's create another table. Predicted using pt.2. Actual natin is using the test data set na, no? Okay, then let's see this. Okay, nagkaka-error ay, wait. Okay, so may error tayo, no? Okay, alam ko na yung error. Pero medyo mahaba-haba itong process na to kasi may babalikan tayo. And I don't think we have time kasi alam ko may mga commitment si Leonard, may commitment ngayong hapon kaya nga tayo nag-umaga. All right, so ganito na ang gagawin ko, class. I will just as I suspected, no? Kasi si 3.1 it used ang ginamit niya yung ginamit natin dito yung train data set, no? Yung train data set, yung train data set 1,000 plus observations. So yung 3.1 naka-link siya dun sa 1,000 plus observations. Itong test data set natin, ano lang siya, no? Yung 400 plus. So magkaka-problema nga tayo. We will have a problem with this. So let me just change this. We'll not discuss this anymore on next Saturday kasi pupunta na tayo dun sa indicators. But I'm going to send to you the corrected portion starting from here and just give a little explanation. Okay? And then simple explanation lang yun. Tapos lalabas na yung test natin, yung result for the test dataset. Okay? All right. So this is just a sample of what machine learning using, stop recording.